Hi, my name is Jeremy Heath. I'm the Innovation Manager at SES Water, but I'm also the Programme Lead on Leakage for UKWIR. UKWIR is the UK water industry research body. It's joint funded by all of the water companies, and it divides the industry into a series of big questions, one of which is, how do we solve leakage? And I'm the Programme Lead on that. As part of that, I travel around and meet with the various water companies. I did it in October 2023, met with all of the water companies individually and discussed the research and innovation needs that we require in order to meet our targets. And at the moment, I will be honest, we need research and innovation because we have some very challenging targets and we're struggling to meet those. The National Infrastructure Commission did an audit last year and they said, look, the supply gap by 2050 is going to be 4,800 megalitres a day. And a third of that supply gap will come from halving leakage by 2050. That's the goal that we are all working towards. The trouble is we're not meeting it. About half of the water companies at the moment are failing to meet the reduction targets. And so it is a very challenging time for our industry, and we need research and innovation to help us meet those targets. So how do we do that? We know that there's not a single solution out there that solves leakage. And so what we do is we divide leakage into 4 areas. And in order to solve leakage, we've got to do all 4 of these really, really well. We talk about it with the acronym PALM: prevent, aware, locate, and mend. And what I'm going to do now is explain to you those 4 areas and what we're trying to achieve in them. So let's start with the first of those, prevent. How do we stop leaks occurring in the first place? Most of us will have very old networks in our area. In my area, some of our mains go back to 1860. They're buried a metre below ground. It's really hard to know the condition of that pipe. And it's even harder to know how it's deteriorating over time. And yet we know that we need to go in and do mains replacement programs, and we need to target those very effectively and carefully so that we pick up the worst mains. And it's not a simple matter of age. Some of our oldest pipes are actually in the best condition. So we need to build models and we need to take measurements of these mains so that we can understand how they are deteriorating over time and what causes that deterioration. Is it the ground conditions? Is it the surface loading? Is it other factors that affect the deterioration of that pipe? We're not going to be in a position to replace all of that pipe very quickly either. It will take decades and, by some estimates, centuries to replace all of our mains. So how do we make best use of the mains that we've already got? Well, one of the things we can do is try and calm our networks down. We know that when we open valves or turn on pumps, we send pressure waves down and up the network. And what we need to do is calm the system down so that those pressure waves don't simply move through, find the weakest point and cause a burst. And the other thing that we can do is just reduce the pressure in areas. By reducing the pressure, we have 2 effects. Number one is if there is a leak, the flow rate of that leak will be lower. But what it also does is it stops the stress and the strain on that pipe. It reduces it, and so we've actually made that pipe last longer as well. So there's a number of strategies that we can do in prevent to actually increase the life of our mains. The second area is aware. How do we become aware where leakage is breaking out? So in order to understand that, we divide our entire distribution system up into what we call district meter areas, DMAs. Those DMAs are typically about 1,000 properties. And we monitor the flow going into that area, and what we're looking for is a change in the flow rate, a jump that tells us a leak has broken out in that area. The trouble is that can be masked by usage as well. So we're bringing in some really good analysis tools now, machine learning, artificial intelligence, to do that analysis and tell us, is this a leak or is it usage? Is it one big leak? Is it lots of little leaks breaking out at the same time? So that we can understand and be aware of whether we go and look for leaks in that DMA. But the other bit of awareness is saying, okay, where in our components is leakage occurring? And by that I mean we have treatment works, trunk mains, service reservoirs, distribution mains, customer supply pipes, and then their properties where we monitor their leakage as well. Leakage could be occurring in any one of those, and we need to be able to divide it up and go, okay, some of this leakage is occurring on our trunk mains, some on our distribution, some on the supply pipe. Do we know how much? So part of awareness is understanding the various components as well and understanding how much they're leaking. So if we have awareness and we now know where the leaks are occurring, the next thing we need to do is do location. So that's the third one, locate. In the past, this would mean putting staff into an area, and you may have seen the old pictures of people listening on pipes. We still do that. We still go and listen on the major fittings, but we also have a whole toolbox of new techniques that we can bring as well. We obviously have digital acoustics now, which are far better at being able to isolate those sounds. But we also have accelerometers that can detect the vibration that comes from noise. We can put that on a hydrant or on a valve, and it will actually pick up that vibration, and it will tell us, I can hear something on that pipe. In fact, if we have a network of those linked together, they can communicate and they can actually say, I can hear the same sound slightly louder or slightly quieter, and it allows us to work out the rough location of where that leak may be. We've got increasingly intelligent systems coming through as well with things like satellite systems. Satellites flying overhead looking for the characteristic signature of chlorinated water. And they can tell us there's a hotspot here. There seems to be something leaking in this area, so we can then go and investigate further. We're doing a lot of work at the moment on dark fibre. Down a lot of our roads, there are fibres laid by the various companies in order to carry internet. But they won't light up all of the fibres with data. Some of them will still be dark, put there in readiness for when they might be needed in the future. We found that actually you can pass a signal down those dark fibres, and you can use that to detect the vibration of a leak, and again, localize. So dark fibre is one of the areas that we're looking at increasingly. And then micro pressure variation. When a leak occurs, you get a little localized drop in pressure, and some of the clever systems coming through now can detect that little drop in pressure and localize the leak down to a street level. So prevent, aware, locate, and the final area, mend. Mend is the area where we're seeing the least innovation. One of the reasons for that is typically we pass all of the mend stuff over to our contractor and we say, please go out and repair these. The only time where we really communicate with our contractor is when the work in progress gets too high and we want it beaten down quickly. But actually, there's a load of innovation that we can start to do on mend as well to try and speed up that repair process. So what we need to do is look at low dig and no dig methodologies. So low dig is saying, can we do microsurgery, keyhole surgery on our pipes? Instead of having to dig a hole big enough for a man to get into, is it possible to do a small hole on the surface and then go down through there and carry out the repairs from the surface? Even better, of course, is no dig solutions. The ability to go to a hydrant or an access point further away from where the repair is required, place something in the pipe that will go along, find the leak, and then seal it from the inside without the need for any excavations whatsoever. At the moment, only about 11% of our innovations are on mend, but 52% of leakage spend is spent on repairing, mending the pipe. It's an area that's ripe for innovation. But all of these need to combine. We need to do all four brilliantly if we're going to bring leakage down to the levels that are needed by 2050. We need to do prevent, aware, locate, and mend if we're going to halve leakage.